Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the factor affecting IR spectroscopy. And so far we have discussed there are four factors which affect the IR frequencies because specific functional group has particular frequency, stretching frequency, and sometime that specific or that particular stretching frequency either increases or decreases, or the stretching frequency of that particular functional group, the position of that peak either shifted at lower or in some cases at higher. And why this so? This is due to the factor which are responsible for shifting the IR stretching frequency from the normal values. Suppose the normal value of cationic carbonyl group is around 1715 per centimeter. The shape and size is very recognizable or very noticeable. The organic chemist, by looking that peak or band, they immediately come to know that this peak is due to carbonyl group because its shape and size of that particular peak or the band is definite, but in some cases only the IR frequency either increases or decreases due to the following factors, which are the factors responsible for increasing or decreasing IR frequency. Number one is a inductive effect, number second is a resonance effect, number 3 is a hydrogen bonding, and number 4 is a steric effect. These are the four factors which increases or decreases IR value than the normal value of that particular functional group. These are the discussion we had discussed in our previous lecture. Today, what we are going to discuss, now just look at the blackboard. What is written on the blackboard? Application of IR spectroscopy. And as we know that the IR spectroscopy, or just as a spectroscopy means what? The interaction of electromagnetic radiation with matter is known as a spectroscopy. This is the simplest definition of the spectroscopy. And IR spectroscopy means what? You just remember IR correspond to functional group. There are different functional group present in the organic compound, and that different functional group has their IR frequency at a particular value, stretching frequencies of that. Suppose as the hydroxy groups are there, the hydroxy group, appearance of that hydroxy group appear around 2500 to 36 per centimeter. These peak tells us the broad and the strong peak is due to the presence of hydroxyl group or carbonyl group. So that type of and mainly remember every and each spectroscopy has their first application, which is the determination of the structure or detection of the structure. This is the most important or the prominent application of every spectroscopy, because at T.Y.B.Sc level we are going to learn 3 spectroscopic methods. Number 1, UV spectroscopy, that we have already learned. Now second one is IR spectroscopy, we are presently learning, and in a future we are going to study, which is NMR spectroscopy. And these are the 3 spectroscopic methods we are going to discuss, we are going to learn in this semester. One which we already discussed, and second we are presently discussing, and third in future we are going to learn that one. So let us see first application of IR spectroscopy, the determination of structure of molecules. First one is the determination of structure of molecules. First application is a determination of structure of molecule, determination of structure of molecule, determination of structure of molecule. This is the application which we are going to discuss over here, and this is the first application. In that first, this is the first of determination of structure of molecule. Here we are going to see the functional group, which we are going to learn here. Functional group region, or functional group region you can call it here, functional group region. And it is very important as far as the absorption of peak in functional group region will help us to detect the functional group present in the molecule. The observation of peak in a functional group region will help us to detect the functional group present in the molecule. Let us say here, suppose carbonyl group is present, and as we know that carbonyl group is present in a different molecules, different organic molecules such as aldehyde, carbonyl, acid, ester, acid halide, amides, lactone, lactam, acetic anhydride. The name which I have just mentioned here, all these organic compounds containing the common name, containing the common functional group, which is a carbonyl. And if you observe the spectra of those molecules, you will observe the peak around 1715 per centimeter, that clearly indicate that the presence of carbonyl group in a particular unknown organic compound. This will be the first application of IR spectroscopy, which is determination of structure of organic compound unknown. And by comparing these signals, suppose let us see there is a carbon-carbon double bonds are present, and as we know that the carbon-carbon double bond, it is present in alkene, as well as it is present in the aromatic compound. So how do you distinguish these two kind of the carbon-carbon double bond from each other? One is a alkene or the olefin we can call it, and another one is a aromatic compound. And as we know that aromatic compound and the aliphatic compound, theoretically, how do we distinguish? It's very simple. Those organic compound obeys Huckel's rule that all the organic compound are termed as aromatic compound, and the rest of the compound we can call it as a aliphatic compound. That is one of the simplest tip and trick to recognize the aromatic compound from aliphatic compound. But by IR spectroscopy, we know that by observing the particular peak, from that organic chemist definitely knows that this peak is corresponding to this functional group, this particular peak is corresponding to this particular functional group. For example, the carbon-carbon double bond and the carbon-carbon double bond of aromatic compound, the peak appear around 1500 to 1600 per centimeter. That clearly suggests that there is a presence of aromatic compound in the unknown organic compound. And from that, by observing that particular peak, we also come to know that the substitution pattern of the aromatic compound. Substitution pattern means meta, ortho and para, by looking that signal. And now suppose there is a olefinic carbon-carbon double bond is present, the peak will be appear around 1620 to 1640 per centimeter, or let's see 1650 per centimeter. That clearly suggests that there will be a carbon-carbon olefinic double bond is present in the organic compound. So, or let us see, suppose there is a halides are present, and as we know that halides are produce the peak around, suppose let us see 600 to 800 per centimeter. From that the organic chemists come to know that there is a halide atom or the halide groups are present in the organic compounds. So that are the some of the important trick you should remember while assigning or while interpreting the IR spectra. So one of these, the observation of the peak in a functional group region will help us to detect the functional group present in the molecule. And if peaks are shifted to higher, suppose if peak is or band is or the signal is shifted to higher or lower value, then the expected values indicate presence of either inductive effect, resonance effect, hydrogen bonding or steric effect present in the molecule. Thus, if compound contains only one oxygen atom and IR peak in the region of 1690 per centimeter, Most probably it is alpha beta unsaturated ketone, as we know that this one. Let's see, suppose here we have this compound and another compound is this one. And if you observe these two structures carefully, this is a structure number first and this will be the structure number second. If you take the IR spectra and that IR spectra will give the appearance of peak around 1710 per centimeter, which clearly indicate that there is a normal value of carbonyl group. If that is a saturated ketonic group, indicate that the normal value should be 1710 to 1715 per centimeter, which is a characteristic of IR frequency of carbonyl group. Let's see this one. If you observe this structure carefully, what do you observe here? Alpha beta unsaturated compound, this one. Now if you compare only the shape and size of that carbonyl group will remain same, only the position of that signal, that peak is either at higher than this normal value or lower than this normal value. And as I already told you that there are 4 important factors which increases or decreases the IR values from the normal value. These are the 4 factors responsible for increasing or decreasing the IR values than the normal values. And now let's see over here, this carbonyl group shape and the size of that carbonyl group never change, only the signal will appear around 1619 per centimeter. It is slightly less than 1715, but it is a slightly 1619 per centimeter. The shape and the size of that carbonyl group remains as it is. It is very much same whatever the normal peak value of that carbonyl group, but the IR peak, the frequencies are lower down. Why this one is a lower down? If the situation permits like this is a Enon system, or we can call it as a alpha beta unsaturated compound, this one. And as we know that alpha beta unsaturated compound, there involve as a resonance structure, and due to that resonance structure, here electron donating group of that, if you draw the resonating structure of this compound, what you will observe here the O minus, because oxygen atom is more electronegative than the carbon atom at beta position, there will be a positive charge. If you observe this structure, second structure carefully, these two structures are canonical form or resonance form, and these two forms are nothing but as a, what we can call it as a, this one is a due to the resonance effect, double bond character decreases. Double bond character decreases, or you can just say single bond character increases. Once the single bond character increases, what is happening? Force constant decreases. Once the force constant decreases, the frequency automatically decreases. because force constant and the frequencies are directly proportional to each other, and therefore if the frequency increases, force constant also increases, bond strength also increases, and that's the reason why this alpha beta unsaturated carbonyl compound, the peak appear around 1619 per centimeter. In addition to this, let's see, however, here you will get as another distinct peak is appear around is 1620 per centimeter or 1610 per centimeter, and this is clearly indicate that there is a carbon-carbon olefinic double bond is present, and it is appear around 1620 per centimeter. And by observing these two peaks in the IR spectrum, you can definitely say that here this compound is having two functional group. One is a carbonyl group, the peak around 1619 per centimeter. Another peak is 1620 due to the presence of carbon-carbon double bond. In this way, we can easily find out, we can easily distinguish these two compounds from each other by observing their IR values. Understood this one? Now, let us move on to the next point. Next point which we are going to discuss over here, that is the second point, is the fingerprint region. As we know now, second B point is a fingerprint region. Fingerprint region. Fingerprint region, and here in the fingerprint region, how this fingerprint region is helpful or help us in comparison for the two samples. As we know that fingerprint region is a very complex region. It is not much useful as far as the organic chemist point of view is concerned, but it is helpful for the sample comparison. If two samples are identical, then their fingerprint also as identical. So that type of the conclusion we can draw from this. And this, the peak in this region are very characteristic of the molecule. No two different molecule can have identical IR spectra in this region, and if they have, the two compound must be one and the same, and thus comparison of IR spectrum in fingerprint region will help to establish the identity of the molecule. So this will be the what we can call it as a identification fingerprint region. So if two samples are identical, then their fingerprint also as identical, and these two compounds are one and the same. So that type of the valuable information we can obtain from this fingerprint region. Now let us move on to the third point, that is the C over here. As we know that the aromatic region here, aromatic region. As we know that this is all are the functional group region belonging to these three, that is the aromatic region. And just now I already mentioned that the CH bending vibration in this region helps to know the substitution pattern in aromatic compound. As we know that generally benzene is a ortho substituted, meta substituted, and the para substituted. That type of the pattern also we can understood by, and at that time they are, suppose there is a, this is a monosubstituted, and when it is disubstituted X over here may be as a, here you can call it as a Y, or this can be here X and here may be as a Y. This is the ortho substituted, this will be the meta substituted, and third one may be as a para substituted. These are the substituent pattern ortho meta by observing as a CH bending here, CH bending vibration. And if the in the aromatic region there are number of peaks are observed, from that we can clearly say that there is a aromatic compound is present, and that bands are generally appear around 910 to 950 or somewhere 850 to 910 per centimeter. So that are the sum of the peaks is normally seen in this bending vibration, and from that we can come to know that whether there is a aromatic compound is present or not. Suppose in the aromatic region there is no 2 or 3 such type of the peaks are not observed, means there is a lack of appearance of absorption peak in this particular region, clearly suggests that there is non-aromatic compound is present. Understood this one? Lack of means absence of this peak in that specific region, that clearly indicate that the organic compound may be as a non-aromatic in nature. Lack of peak, absorption peak in this particular region are known as non-aromatic compound. So in this way we can easily explain this one. And now I think this is one of the first and the important application we have discussed over here. In the next time, in the next lecture, we will discuss about the second application, which is very important as far as exam point of view is concerned, and many of the questions appear on it. Study of progress of chemical reaction, that we will see in the next time. So still then, let's stop today here. Thank you. Have a nice day.